Hello, folks. Welcome to part 11 of the C++ tutorial. Today, we're going to be looking into advanced file management. On a previous part, we saw, the upstream and iStream. Today, we're going to be concentrating on the F stream, text files, binary files, how to append, how to seek, how to replace a record in C++. And so we're gonna how to save structures and all that stuff. I hope you enjoy this tutorial. So let's get to it. All right, guys, so we have a few files that we are going to be working with. Sorry, I was showing something. So anyways, here we go. The first thing to do is the basic file operations, okay, through the magic of copy paste. Here I have a file. I'm going to be using IOStream. Of course, I'm going to be using FStream, which is a requirement when we're working with files in C++. And in this example, I'm using strings. I'm going to be using the object string, right? So namespace SPD. Here is my declarations. All FStream. This is a what we saw in a previous file management file example in my another part of my tutorial. So OF stream, O file, IF stream, I file, and then I have my name. And my name is equal to Ray Ojeda, my name. So I open the file and I write information into it. So O for out, right? For out file, O file dot open. Here's my sample. It's a text file. And I put my name, which is this string right here, into O file, and then I close it. There it is. And then I just open the file. So now I'm doing ifile sample txt. Remember, ifile subtype ifstream. I get line. I'm using the get line function to import from ifile and then the string, which is my name. And then I close it, and then I print out, see out my name. So let's see how this works. Let's do a run. And there it is. It prints out my name right there because I created, a file sample txt. This is kind of like a recap of the basic file operations using OF stream and IF stream. Okay, so now let's do another example. And I'm going to, here it is. Here's my second example today. This time I'm going to be using the F stream. So the other way was using OF stream and then IF stream. Obviously, automatically is for out or for in. Here we're going to use F stream, and what F stream does is it allows you to do in and out at the same time. It could, depending on your flags that you use. So the only modification here is that I'm using FStream. Of course, it's the same. And here it is. FStream is, and I'm naming it file. That's the name of my object. It's an object. Same string. Now, this is a big difference right here. So I open the file. Here's my name of the file, sample txt. But this time, see how it says mode right there? And I can do in and out at the same time. I can input and output. I can do both. So from file, I put in the data into it and I close it. I'm going to do the same thing. And this time I'm going to do get line, and then from file, my name. And you can see the little ampersands right here. They're put in automatically by my C-line editor, but because I'm sending the addresses right of these objects. And I close it and I print it. This will produce the same output as the other one. It's just going to print my name. Now, one thing to notice before I continue to my next example is that when I do file open and I put in and out right here without any other parameters, if there's a text file with that name already, the contents will be deleted. Okay, so sample txt, I'm not doing any checking of if the file is here, not checking if there's any contents in the file. I'm just saying, look, open up sample txt and put my name into it. and it's going to erase whatever's there. So that's one thing you gotta watch out when you're doing this. But in the purpose of this example is for you to see that you just open it, and I can do in and out. And this is called a flag. Says iOS : in. The pipe means I can do more than one flag. I can do iOS out. I could have done just in, and I could have done just out. Okay. So, I could do one or both. In fact, there's more flags than just this. There's append and there's uh anyways, there's more. Those are the ones that I normally use, but we have that. In my blog in WordPress, I put in a image with all of the different flags because there's multiple of them. I normally use 3 of them. Well, 4 including binary, but in this case, in and out, I automatically put both of these in here. Even if I only need one of them, I automatically put both of them. So anyways, that is example number 2. But what if I wanted to append a file? As I mentioned, the file is already there. The file's already there, sample txt. So here's my same includes my namespace. Now, this is the file. This is my C++ file. Again, I do file, I string my name and my department. So I have an additional object here called my department. So this is what I'm going to do. I'm going to open sample for in and out. See, same thing. Now you notice I put a capital S. It doesn't matter, right? It could be lowercase or uppercase because it's a file name. It doesn't really matter in this case. Now this is something new. If file.fail, what I'm doing right here is I'm asking C++, did it fail? Okay, that means it's not there. If the file's not there, open the file in out. See, here's the mode. See how over here I got both modes, input, output. But if it fails, that means the file does not exist. So create one. So I'm gonna open it up for output. File does not exist. What is your name? And I'm gonna get line, my name, and I'm gonna put it in the file. I'm gonna close it, and the file is created successfully. If the file's not there, if the file is there, the file exists. So the first thing I'm going to do is close it. I'm going to ask for the department. I'm going to open it, and I'm going to do it in append mode. See right here, append. What this is telling the program is to go to the end of the file and enter another line, and then successfully append the file. So that's what they're going to do. Let me run the file. And what department do you work for? I'm going to put in information technology. And there, I appended the file. Very straightforward. So by default, the append means you can, input to the file, okay? By default. Some people can put in and out and append and binary and all these things. You can combine them all. It doesn't really matter. Some will have precedence over the other. We'll let the compiler worry about it. But append means go to the end and add. Whatever I do it at the end. And I'm still dealing with just text files. I had already done a file, so it went automatically here and said, hey, let's see what's in there. So that's what this does. Again, see here in and out. If it fails, that means it's going to create a new one. If not, go and append the existing one. And that's how you would do that. I'm going to do another example. This time, I'm using functions. So I include my IOStream, FStream, and string using namespace std. Now I got 2 functions here. One is open file, and this is the I'm sending the memory address, and then it's a string, and then print file, and I'm sending the memory address of the of my file name. So let's go to the functions first, and I'll go to the main. So here's my open file. I have fstring ampersand file and the file name. So I'm asking for the file. I'm telling it, hey, I'm going to receive a file, and then I'm going to receive a string. File open. Here's my file name from here, right? And an input way. I'm going to input from it. If it fails, return true. I'm sorry, if not. See, look at this exclamation point. It's an if not fail, return true. That means it was successful. Otherwise, return false, right? The other function is to print it, and I'm going to get the address. Remember, every time we see ampersand, think memory addresses, think pointers, right? But it's the memory address of my file name. Well, before I jump into this ampersand file here, here's my file, right? So I'm talking to the same object. So over here, I do a string str, I get line from file name str, and I print it out. So I'm printing out what's in the file. Now, going back to my main function, I have my file name right there. I open up, see if it's a function. It's an if statement, right? And then open file. Open file is this, which is a Boolean. If file name, and then here's my sample txt. Here's my file name, and this is the file. It goes here, and this is going to return either a true, if not fail, or a false. So it's going to give me that. Depending on what I get back, it'll say file exists or file does not exist, right? That's what this program is doing. So let's run it and see what I get. And then it says file exists. Ray Ojeda, Information Technology. Remember, I put in my name on the first example, and if it was there, I appended information technology at the end. So that's what this program does. It exists, so it prints it out. Very straightforward. I'm going to browse a little bit slowly so you can see the code. In case you want to copy the code, you're welcome to copy the code. It is not copyrighted. It's C++, my friends. This is awesome. All right. So what if you want to read multiple lines? Okay. I'm going to create another file here, another example. Now here's my open file, my print file. See, I got everything's the same so far. If that exists, print file name, close, file does not exist, return. Open file name and get line. So, and it looks like the same as the other one. I think I'm doing the same thing. Let's see, run this file, and file exists, and now is there twice. Okay. Yeah, so this is equivalent to the other example. I'm going to leave it on the screen so you can see the code. Let's go up to the main. There we go. So there's not much to show in that one. Now, let's go to our next example. It's a very short program. My stream, here's my stream. I'm doing something different here though. I have a structure called main DB. That's the name of the structure. This right here, main DB. And in my name DB, I have a char first name, which is 20 characters, a last name, and age, right? And I'm initializing it to the name to the variable person. So person is of type main DB, and it contains a first name and a last name and age. I'm gonna use the function strcpy to copy. Into the first name, I'm gonna put my first name. Into the last name, I'm gonna put my last name. In my age, I'm gonna put in, I'll change that to 35. I want to feel younger. So I'm gonna open, now this time I'm just gonna open a different file. It's in binary format. Look at this right here, binary. When I put the iOS colon binary, I'm telling C++, open it in binary format. You can put in any extension that you want, by the way, on any of these files. Doesn't really matter. I mean, neither Mac nor Windows will care, but it's always good to have some standards. Normally, if we put txt, we know it's a text file, right? If it's a binary file, it could be the bin, dat, I mean, whatever you want. I decided to do person dat is a binary. Now, what's the difference between a binary and a text file? Well, I really suggest that you go into my blog at WordPress to see it in writing, but I'm gonna tell you right now, while in text file I would put the letters A, in binary I would put the binary number for the letter 60, for the number 65, which is character A. So we're talking zeros and ones as opposed to actual characters. Is not encrypted, okay? This is not an encrypted file. It's just in binary format. Now, in C++, there is a way to write, everything is written in character format, if you will, a binary part of the character. Characters are very close to integers because they have an ASCII equivalent and they can be done into binary. Okay, so with that said, we use this reinterpret cast and then sharp pointer and then the memory address of person, size of person. Now, what am I doing here? I put in my first name, Ray, my last name, Ojeda. I used a strcpy for both of those. I put an H. So I got one record. And then I'm opening person DAT to put information into it. And it's binary. Now I'm saying I'm going to write to it. I'm going to use the write command. But I need to use the reinterpret cast character asterisk. This we're going to see in the remainder of the examples from here on, because we either put in a char or we reinterpret cast into a char. How about that? And when it's a structure, you can send the memory address of the structure, which is person, if it's one record. Okay, if it's one record. If it's more than one record, if it's an array, I take the ampersand out because I don't need to. When you send an array, it automatically sends the memory address of the first record. So you don't need to put the ampersand, just put the word person. In this case, I'm only sending one record, so I need to put the ampersand person. And then size of, always use the size of so that you know what the size that you're sending to your file. And then I'm going to close it. So write, reinterpret cast, this right here is the key. Okay, right there. Now, I want to print it out. I remember I closed it. So from this point on, and doing something else, I'm going to open it again. This time in, again, binary. I'm telling it it's binary. And I'm telling it that it's for input. I'm going to read. Instead of over here was a write. Here is a read. Again, reinterpret cast, char, person, size of person. Everything is the same except for read instead of write. And now I can output my information. And so let's run this. And there it is. Ray Ojeda is 35 years old. Just like that. Because Ray Ojeda is 35 years old. So again, reinterpret, cast, char, asterisk. This here, you gotta write it down, my friends. Write it down. You're gonna need this. And as long as you're not very, don't have a lot of experience with C++ and you're, especially if you right out the back in 1 week, 2 weeks want to learn the language, and there's all this information given to you, you may not remember all of the different things you can do. Write it down. This is a requirement for files. And remember this, ampersand when it's one record, no ampersand when there's multiple records. Obviously, we use the size of, and I do the write to write it and the read to read it. And there's the file right there on the screen. The entire program is on the screen. There's no, I don't need to scroll. So very straightforward. I like it. Okay, let's do another example. This time, here's my code. Very small program here. Fstream and IOStream. Okay, Fstream file, file.open sample txt for output, right? If file, I'm gonna input my name, information actually, and the date, and close it, and file created successfully. I'm gonna call this sample txt. So if file, remember when I had the file dot fail, this is the opposite. If file means if it's there, if it exists, if I can create this file, not if it exists, if I created it successfully. So I'm going to run it, and file successfully created. And all I did was open up sample txt and input into it. If the file was there, it just got erased, and I put that in. That simple. I did not use an append here. So anyways, I got another example this time, working with multiple files. Why would I want to do that? Well, sometimes, well, first of all, if you have a small program, you are going to be using multiple files. But in this case, let's say that you want to copy information from one into another. I just created sample txt, which has my name in it and whatever I edit, right? So now I'm going to do fstream file 1 and file 2. Here's my string. Now I'm going to open sample txt, the file I just created, in input mode right there. And I'm going to say if file 1, that means it was successfully opened, open file 2 for output right there. And I'm going to call it with the extension BAK. Why am I doing that? Well, I've thought of this example like a backup. So, BAK, so usually I know backup is not BAKUP, it's BACKUP. But in the old days of DOS, which is one of the ones I learned back in the good old Turbo, Borderlands Turbo C++, BAC was the backup, okay? We use BAK for the backup. So if file 1 is successfully created, open file 2. If successfully created, get line from file 1, the string, and as long as I have file 1, input the information into file 2 and get line. And then I close both files. Now what's happening right here? I don't know how many lines there are in sample txt. As far as I know, there's only one. But let's say there was 10 or 100. This is telling, hey, as long as, because every time you read a line, by the way, we're going to get into the flags in a little bit, but the flag, a flag that keeps moving as to the positioning of the file. C++ actually knows that. I mean, every time you open a file, it starts from 0, but when a file is open, it keeps moving that flag unless you move it, on your own. And so, which we will be doing in a few more minutes. But so what I'm saying, hey, while it's open, while it's not done and not at the end of the file, keep reading and printing. I mean, saving. So it's copying from one to another. So I'm going to run it, and that's it. No messages. Basically, now I got two files, sample txt and sample BAK. Very straightforward. Here's the code completely. I'm going to slowly scroll so you can see it. All right. Now I'm going to do this copy. I use copy paste because it's faster than typing everything. So this is a 3-part program. This is the first one. This is part A. And in here, I'm writing in binary. So here's some constants. The size of my name field will be 21, and the size of an email field will be 51. And I'm saying, look, struct DB, this is the name of the structure. There's name and email and age. And of course, these two have constants. Could I put here 21 and 51? Absolutely. It works the same. In fact, my very last example, I don't use constants. I put the numbers. But let's continue with the program. So there's my structure. I go back to the program. Now I can see the whole program in here. I declare person of type DB. There's file, there's int I and double D. Now, before I continue, I'm going to save into a file a structure and an integer and a double. Right off the back, I'm telling you, this is not normal. You're going to see this in many books. You're going to see this in many examples on the web. People will put in a name, an address, a number, a zip code. Totally fine. C will let you do that. C will let you, any program will let you do that. Basic, Pascal, they were all going to let you do that. But it's not normal. It's not what you would normally do. You know, if you're using structures, that's all you're going to be saving is structures. If you have text, that's all you're going to be saving is text. Normally, you don't mix and match. But in this case, I want to prove to you that it will work. So I'm asking for a name, an email address, an age, then a number between 1 and 100, and the cost of gas. I couldn't think of a double. So I say, hey, now that everything is going, we're in July of 2022, gas is going up because of various political reasons around the world. So let's try it out. And I'm going to open up sample 3. Obviously, I'm using a different number with the extension BIN, and I'm in binary mode, right? If successfully, I'm going to save it. Now look at this. I'm using the reinterpret cast char. It doesn't matter. Now, again, one record. Here's my ampersand right there. Person and size of person. But over here, it's to the integer and to the double, right? And the size of an integer and the size of a double. Now, what's the difference? Well, as you know, different number of bytes for integers and doubles, and of course, different for a structure, right? But we need to know that when we're designing our programs. Obviously, we know the sizes that we're of the files that we're creating. And then I'm going to close it. So, and I call this sample 3 bin. I didn't want to mess with the other files. So here we go. What is your name? Ray Ojeda, R Ojeda at mail dot, I don't know, com. Doesn't really, this doesn't exist. I'm gonna put in XXX or XYZ. There we go. So the email does not exist. And then my age, I'm gonna put 35 again, 35. And a random number, 45, 46. And the cost, I don't know, like $5.99. Really ridiculously expensive in the United States. And so anyways, here it goes. File created successfully. So I saved a file, a structure, an integer, and a double. Now let's read it. So to read it, this is part 2 of the this program. So again, the same, my structure, the sizes of my email name, everything is here so far is the same. Here's where it gets a little different. I'm going to open up the sample 3 bin. This time I'm in input mode, still in binary. If successfully, I'm going to read, and I'm going to read them in the same order that I saved them. First, I had my structure, then my integer, and my double. If I change the order, guys, I'm going to get a lot of junk in my screen. C++ is not going to give me an error. Make no mistake about it. It's just going to print stuff that is not good for me. It's not going to help me in any way, shape, or form. And then I'm going to put it on the screen. So if I run this, there it is. Ray Ojeda, my email address, my age, the number, and the cost. See? I just read what I saved. The key here is you gotta save it in the same format that I mean, read it in the same format that I wrote it. And I put it in the structure first, then an integer, and then a double. It will work. It will work fine, but it's not recommended you do it. Again, the only point of this is to prove that you can do it. Normally, you only save a structure, you save nothing but structures, it'll be the same size all the time, which is, that's the way, that's what you really want to do. But I wanted to prove that you can put in multiple. In fact, if it wasn't a structure, I could put a string, a double, a this, a long in, whatever. It'll save them. And as long as you read them in the same order, you're going to be fine. especially if you have more than one record. That's when it gets more complicated, obviously. Um, now, here is the third part of my same program. Again, everything's still same. I'm going back to my main. I don't need to see this because this is the same thing right here, same. Going to my main. So now I'm saying, hey, look, for int equals 0 through 4, which is 5 records, correct? I'm gonna input the name, the email address, and the age, and I'm gonna put them into this respective um, fields of a structure. I'm going to use a sin ignore here because I'm doing this here, the to the age, and then I'm going to open this in binary, and I'm going to oh, look at this right here, binary for output, but look at that, append mode. I'm doing 5 records, so I'm going to append to them, and then I'm going to, I just had to do one. See, I don't have to do the different ones. It's just one, the person. Every single time is just one record, but I'm doing it in append mode. So I'm going to, I already have a person bin, I believe. I'm going to check that I have, let's see, or person bin. I think I already have that. So I'm going to delete it. So when I run my program, I can start it from fresh mode. So there it is. So it's going to ask me for my name 5 times. I'm going to put in Ray Ojeda, R Ojeda at mail.xyz 35. That was my first record. Now I'm going to put Mary Johnson, M Johnson 12 at email.edu, and she's 18. My third record is going to be James Smith, and it's going to be jsmith at mail.edu, and he's going to be, I don't know, 43. Got 3 records so far. Let's do the fourth one. I'm going to put in Tony Marcus, T Marcus 12, sure, at email.edu, and he's 32. And I got one more, my 5th record. I'm gonna call it I don't know, Robert. We had a Tony. This one's Robert. Robert I don't know, Paris, I guess. R Paris at email dot, this one's com, not edu, and the age is gonna be 33. And there it is. Works. It's 5 records, and I added them to my file person bin, which is binary in append mode. All right, so for now, we'll leave that file there for now. There's no need to do anything to it. We're gonna use it in a little bit. Now we're going to seek. So check this out. I have my IO stream, F stream, and name saying, now here's my structure, my name, 21, email and age, and it's into the database. It's going to be into the object person. Now, remember I had the const int for the sizes of my name and email. Here I put the numbers 21 and 51. Perfectly fine. I have read in books, they really like it. You know, the authors, the guys that are 10,000 times smarter than me, they really like to use the const int everywhere. I personally go half and half. It really depends. You can do it or you cannot do it. In this case, I decided not to prove that it will work. Have long rec size int. This is my my functions. I'm getting a long for the record size, and I'm sending an int, and then I'm printing a record with the type of the database DB, right? So let's go to the functions before I do the main. So here's my long. Long rec size in position. Position is the record, okay? It could be 1, 2, 3, 4, or 5. And I'm going to return the size of the database, whatever the size in bytes is for my structure, times the position. Remember I told you when you open a file, it puts in information every so often, every so many bytes, right? Depending on the structure size, or if it's an integer or a double. I mentioned that you don't want to really mix and match the, the variable types because it really is complicated. But if you all do have is structures, then you want to multiply the size of the structure times the position, and it'll give you a long. You need a long. The other function here is p record. Prints the record. It gets R. I just named it R. And all I'm doing is printing the name, the email, and the age. That's all this is doing, is printing it out. Now let's go to the main program. I open up person bin for binary. It's file, our file. If successful, if file, I'm gonna print out the record. I'm gonna say record, and then I plus 1. Remember, I start from 0, but for the user, it starts from 1. So the record starts from 0 to 4, but for the person to see, if they see 0 to 4, they're gonna get a little confused. So we put 1 through 5. And then I'm gonna seek G. Seek G is the area where we want to move to in the, the correct, I put it here, locate the correct byte location. Remember, the structure has a size, so it jumps from size to size. That's what this long rec size function does. Returns the size of the database times the position, and it returns a long. It has to be a long. This here is a long, okay? And then the second parameter here for SIG is from where? Normally is from the beginning, but there are other places you can search. You can search from the end of the database, from the files, you can go to the end and go backwards, or from the current position, move from there. You can do a lot of things, but I personally like from the beginning. That's just me. But there's other things. Again, you go to my blogspot, I put all the little flags in there, but from the beginning is, and this will give me the correct size. Now I can read it and then print it. Here's my printing. So what this is gonna do, hopefully, is print out the records that I created. And there they are. Record 1, record 2, record 3, record 4, record 5. And it prints the email address and the age. This is the file that I just created. Okay, so we know it works. Seek G, a long int, which is the position. Again, the position is actually the size of the structure times the position. And then from where am I searching? Once I move this is going to move the pointer to a particular location in the file. Then I'm going to read it, and then I'm going to print it. Pretty cool. All right, got 2 more examples. We're almost done with this here. So this one's a little bit longer. So here they are. Here's my same structure. I'm working with the same database at this point. Now I have a long, here's my, at the same functions, I'm gonna get the record size, and I'm gonna print a record. This is a long, it has to be a long to the SIG, okay? So these functions are the same. So now I'm gonna say, look, enter a record number 1 through 5, and I'm gonna input I, which is int. And I'm gonna open the same database out for, if our file is open, if correct, I'm gonna seek and print out that record, okay? So I'm gonna run it, and I'm gonna say record, so I'm gonna say, I don't know, I'm gonna say 3. James Smith and jsmith at mail.edu, he's 43. That's all that does. Here, the main thing is seeking and reading is the same thing, but this is how you would search a record and then print it. I'm gonna make this one short because the last one, my last example, is this is what makes everything actually work the way it should. We are now talking random access files. Random means it could be anywhere in my file. Now, why is this important? Look, you can put in a file line 1, line 2, line 3, line 4, line 5, and you can search line 1, line 2, line 3, line 4, line 5. But the reality is, you're not going to do that. The reality is, you're going to, I mean, short of a very few examples out there, you're going to randomly go looking for something, and then you're going to do something with that record. In the previous example, I printed out, what is the record number? 3. Oh, let's print record 3. But what if I wanted to replace something? So that's what this does. Let me see, here's I'm using CC type, and because I have a loop. In my loop, I'm using the function to upper, right? That's the only reason I'm using CC type is for the to upper. Here's the same database, long rec size, the same thing, void print record and void p all records. Now, this one prints all the records. This one expects one record, okay? That's why there's one, and this one is all. So, and now instead of putting it inside main, I'm using fstream file and inti outside. That means that these two are good for the whole program. We're going to go down here to the functions. And again, here's my rec size. I'm returning along. I'm returning the size of person times the position. So whatever position it is, I multiply it and I return. This is to get the correct address or the correct byte size where the file is, right? Here I'm printing the record. It's the same from the previous one. I receive the type of DB that like my person, and then I'm printing it out. This one doesn't need any parameters to print all records because it doesn't really matter. I'm just gonna open the file in input mode, and I'm gonna, as long as the file is there, from 1 to 5, only because I already know it's not there's 5 records, and I'm gonna seek the record size of that from the beginning, and I'm just gonna print them out. All this does is print all the files. Now, what if I didn't know how many records there are? Well, I could do while it's not in the file. Basically, I would do a do while. Instead of a for, I would do a do while not in the file. Okay, I don't have an example of that, but that's all I would do. Now let's go to the main program. The main program is a little bit longer, but here's my record number and here's CH. I'm gonna print all the records, and I'm gonna say, hey, enter a record number or 0 to exit. And I'm gonna input the record number. Now, before I do this, I'm printing all of the records. And the printing of all the records prints a record number, and then the record, which is print record, calls that over here. Yeah, you think I didn't know what I was doing here. Okay, so there we go. In fact, so we don't get confused, let's put it like that. So I print out the record number, and then I print the actual record. So I print out all the records. Now I'm saying which record you want to modify. And if it's greater than 0 and less than equal to 5, right, between 1 and 5, now I'm in business. I'm gonna open this and in and out in binary. I'm gonna seek G. Now, record, I'm getting a number, but remember, we start from 0. The 1 through 5 is for the user, is 0 through 4 for us. So I'm subtracting 1 here times the size of person, and then from the beginning. And then I'm gonna read that. I'm sending the record, the structure right there. This is the same as what I had in the previous example. Then I'm gonna display the information. Then I'm gonna say, okay, so what is the new name? What is the new email? And what is the new age? And once I have that, I'm going to go back in there, and this time I'm gonna save the record. So let's see this in action. I'm gonna run it. So here's my record 1, 2, 3, 4, and 5. If I do 0, it doesn't do anything. And then it says all records, add another record, or whatever. So I'm gonna say no, it exits, okay? It does, that's all it does. But what if I did have a record? Let's say 3. That's record number 3 is James Smith, right? So now I'm asking for a new name. So I'm gonna say, you know what, James, change his main name to James Marcus Smith. He's very peculiar about his name. And the email address, he wants to use a different one. He wants to be jsmith2 at out.xyz. And then the H is going to be the same. He's still 43. He's just a fancy James Marcus. And here it is. Now I changed it to James Marcus Smith, J Smith 2 at out XYZ, and still the same H. See, I printed all the records. Now the record needs to be edited. I'm going to say no, and that's what it does. So once you see the main code here, the other functions are the same. Here's the main functions. This returns the long for the correct position. This prints out a record. This here, I'm printing all the records, so I don't need any parameters. I'm just saying from I equals 1 through 5, subtract 1 here, and print the record. Then over here in the main program, I'm saying print of all the records, and I'm going to have a do while loop. And my do while says, hey, enter record number or 0. If it's 0, don't do anything. If it's not 0, then I'm searching the record, I'm printing the record, and I'm asking for the new information, and I'm writing it out, and I'm printing them all. And the only reason I'm doing this is you can see that it changed the information. And I'm saying another record, I input into CH, and here's my function to upper. While it's Y, it's gonna keep doing it until I'm exiting. So anyways, there it is, guys. I hope you like this example. We're gonna start working into classes now in my next tutorial, so we're getting out there. I hope you liked it. If you do, you know what to do. Please subscribe to my channel, and thank you very much.